All right, so we are in Algebra 2. Today's date is Thursday, December 12th. We are not going to be able to get through this entire packet today, so I'm going to continue this video tomorrow. We'll see how far we can get. The general setup here is I'm going to run through these problems. You guys can ignore me or not. You can ask me questions, but I'm going to just kind of go through this nice and efficiently. We need to find the sum, so I need to add these two polynomials. What it's really asking us to do here is combine like terms. You have your 6x squared and your x squared, so those are your like terms. I'm adding them. I don't have to worry about any distribution because there's no negative. So 6x squared plus x squared is 7x squared. Negative 6x plus 4x is negative 2x, and 2 plus 4 is 6. Done. That's the answer. Box it. Ask me questions. Again, you're just combining your like terms. 6x squared and x squared got to 7x squared. Negative 6x, positive 4x got me negative 2x. And positive 2, positive 4 makes positive 6. Moving on to the next question, unless someone raises their hand for more time. And I don't see any hands. I'm now doing the same thing, but with a minus sign. I'm doing a difference, which means now I need to distribute this negative sign into each of these three terms. So this is now, I can kind of undo my work here. I'm going to say this is a plus, a negative, a positive, and a positive. I'm just switching the signs here. After I switch the signs, it turns into a problem that was number 1, which is combining like terms. And I guess I can zoom in here. I guess you guys can't see very well, right?
I thought you said it was going to be multiple choice.
It is going to be multiple choice. The practice, though, I need to show your work, make sure you know what you're doing. I don't want you to practice your multiple choice skills. I want you to practice your math skills. And that helps you make your note card as well. So I have a negative 6r cubed, a negative 6r cubed, or negative 3r cubed. That makes a negative 9r cubed. Negative 9r to the power of 3. I have an r term, an 8r, a negative 8r, a positive 4r, so that makes a negative 4r. I have a positive 7 and a positive 5, that makes a positive 12. And I have written it in standard form. Standard form meaning that it goes from a highest power from the left to the lowest power on the right.
I wrote it in pen and it bled through.
Oh no. Do you need a pencil?
No, I don't want to be the shame board.
Okay. Find each product. So these, the left one you can probably just distribute and you don't have to worry about it too much. If you want to do it the old-fashioned way, you can say, okay, if I make my box, I have negative x minus 2 and my 8x over here. You can say 8x times negative x is negative because negative times a positive is a negative. And then 8 times 1 is 8. And then x times x, there's how many of those? There's 2 of them, so x squared. And then 8x times negative 2 is negative 16. Negative 16x. And then I just kind of add up the area model and say, okay, the correct answer here is negative 8x squared minus 16x, which I could have just gotten from distributing this 8x into both of these two terms. There's a bunch of different ways to do these problems. I can't go over every single one of them. Shui, can you please not have your feet up on your drawer for your desk? Thank you, I appreciate it. The next one, I'm going to do an area model, also known as a general rectangle. It's kind of the same thing that I did over here, but instead of a 2x1 rectangle, it's going to be a 2x2 rectangle. So off to the side here is my 2x2 rectangle. And it doesn't matter which one goes where, so 4x plus 1, I'm going to randomly say, I'm going to put that on top, 4x plus 1, and negative 2x minus 7. And again, each of these cells is going to be the row times the column. So 4 times negative 2 is negative 8. X times x is x squared, so this first cell is negative 8x squared, and then I have negative 2x. I have negative 28x and negative 7. Usually, if you've set up your general rectangle or your area model correctly, these diagonals should be like terms, more often than not. They will be on the final. I just have to write out my final answer. Negative 8x squared minus 30x minus 7. Done. Box it. Again, that negative 30x came from the negative 28 and the negative 2. I add everything in the general rectangle.
Go back to the other one.
Number 3? Yeah, here's number 3 again. Beverly, do you have a question as well?
Yeah, for this one, can you do that?
Yes.
Is that a shorter way?
Yeah, foiling is called F-O-I-L. As long as you make sure that you actually hit all 4 of those multiplication problems. F-O-I-N-L. First, outer, inner, last. Sam, did your question get answered? Perfect. Yeah, so again, just Beverly's question. First, so 4x times negative 2x. Outer, 4x times negative 7. Inner, 1 times negative 2x. Last, 1 times negative 7. If you do that kind of pattern, that's called foiling, and that is another method. It gets a little bit more hairy if you did a 2-term times a 3-term, a binomial times a trinomial, but you can always do it that way. It's just harder and harder the bigger it is. Number 5. Again, I have the same type of problem, but different because this is a conjugate pair. Conjugate pair meaning it's the same terms, negative 5v, 7 and 7, but the middle term, or the middle operation is changed. So there is a shortcut to this. I'm going to do it the long way. I'll show you a shortcut at the end if you want to see it. The long way is, okay, make another area model. It's going to be a 2 by 2. It's a binomial times a binomial. Never negative 5v plus 7 on the top, negative 5v minus 7 on the left. It doesn't matter the order of those. And then I just multiply. Negative 5 times negative 5, or negative 5v times negative 5v is 25v squared. I'm going to get a negative 35v, a positive 35v, and a negative 49. Gloria, yes?
Multiply the numbers and add the exponents.
Yes, that's a good way of thinking of it. In terms of the coefficients, I always multiply the coefficients, and I always add their exponents. This was a power of 1, power of 1. I added those to become a power of 2. Yeah, good insight. And maybe something that everyone should write down on the note cards as well. I keep calling them note cards, but it's really your sheet of paper. Just like before, these diagonals, top right and bottom left, those are your like terms. That has a v, that has a v. It's a v to the power of 1. That means they're like terms. So what is 35v minus 35v? Well, they cancel each other out. So it's actually 0. And my final answer over here is 25v squared minus 49. And that is my final answer. I like doing it the long way because it's one process that works on multiple problems. So you don't have to memorize anything new. But there is a shortcut, and it's Riley's little nursery rhyme. Or it's not even a rhyme. It's square the first.
Nursery rhyme? It's not for
And then you... you shake the baby a little bit because not the full nursery rhyme. You skip the last line and then you square last.
shake. Did you say shake?
Yeah, because normally the nursery rhyme goes like this, right? Square the first, double the product, square the last. This one goes square the first, square the last. Right? And that's how I always think of these tricks.
No, I'm talking about you rocking your baby.
I don't shake my baby. I saw those signs on the freeway. All right.
If I can fit the whole practice test.
And the other thing that I should always mention, sorry, Jade. The other thing that I should always mention, this is always a minus sign when it is a conjugate pair. If these both match and one is a plus, one is a minus, this sign will always, 100% of the time, be a minus sign. That changes next year. So I'm lying to you, but just a tiny bit. All right.
So magical all the time.
No, that's how you teach as a teacher. You lie to you, and then I tell you why I lied. And you're like, oh, okay. And like, that's how you figure it out, right? It's a nice, easy lie. Math question?
Yeah.
Go.
If I can fit all these problems onto one side of a piece of paper, I can use it.
Yeah. Yeah, it's not a bad strategy. It's just a lot of work, right? All right, now I have a square question. Again, this one has a shortcut, but I'm going to do it the long way. Another way of thinking about this problem is it's 3v plus 4 times 3v plus 4. It's the same thing twice, which means if I'm doing my area model over here on the right-hand side, or general rectangle, I know it has a bunch of names, I'm going to do 3v plus 4 on the top, 3v plus 4 on the left. And again, finding the area of each of these cells, this is going to be 9v squared, 12v, 12v, 16. Again, you should have this property that these diagonals, bottom left and top right, are the same term. They're like terms. And I can add those. So my final answer is 9v squared. I have a total of 12 and 12 of 24v and plus 16. There is my final answer. And again, the shortcut here, you do not shake the nursery rhyme baby, whatever you want to think of it. This one is, if I zoom out here, it's going to be square first, double the product, that's a difference, and squared last. I'll leave that up here for another 10 seconds, and then I am moving on because I see lots of people still writing. We're okay over there, gentlemen. Aurelio, why are you so close to Leo?
I'm helping him.
Okay, thank you for helping him. Let's move on to number 7. I just don't want Jaden to be distracted. That's what I'm worried about.
Everyone was just telling me about the time you couldn't read.
Okay.
It's pretty funny.
Thank you for your honesty, but if we could try to stay on task, I'd really appreciate it. All right, number 7. Now I'm going to be adding, these are now entering the land of complex numbers. I could not, I tried really hard to get a problem that was like I to the power of 47, but I couldn't find any of those in my program, so lucky for you guys, you don't have to remember those. So our first problem is just adding. 5 and 2 adds to 7. Negative 8 and negative 5 adds to negative 13, and don't forget your I. Final answer, done.
So you just add like terms.
Add like terms, yes. We've done similar problems. This is now in complex land, complex numbers. It's the shadow realm, right? Before we were just doing polynomials. Slightly different, very similar rule though. Okay, so now I have to distribute this negative just like we did before. You can see a lot of the mirrored elements. So this negative is now going to be distributed, so it's change all of these signs. So a positive 4 and a negative 4 turns into 0. A negative 4i and a positive I is a negative 3i. My final answer is negative 3i. Colby, question? It's a beautiful stretch at that too. We are moving on to question number 9. Now I'm doing some multiplication. I think the first and easiest thing to see is 5 times 7i, that's just 35i. So let's turn this into the problem. 35i, that still needs to be multiplied by negative 6 minus I. I have to distribute this 35i into both of these two terms. So my first question, 35i times negative 6, well, 6 times, oh boy, 6 times 5 is 30, so 0, carry the 3. 6 times 3 is 18, plus 3 is 21, so 210, and that's going to be negative because a negative times a positive. And I have an I as well. So that was the first term. I just did 35i times negative 6, and that is negative 210i. You will not have a calculator on the test, on the final. The reason for that is because it's multiple choice. You get one or the other.
So
if you would like it for your response, let me know, and I will let you have a calculator, and you will get no multiple choice. I can make that accommodation. It's not that hard for me to do.
you can't do mental math.
If you can't do mental math, if you want to do multiplication, I can print out a multiplication chart for you. I have a few backups in my desk. Let's see if I still have some. No. I can print out some more, though, and laminate them. How many people, by quiet raised hands, would like a multiplication chart? Okay, 1... Only one person. 2. You already have one, so you're good. All right, I will print out 2 unless you ask me privately, and I can go make those. They take about 5 minutes a piece to make because the lamination machine takes forever, but I can make those. Beverly, do you mind doing me a favor? Can you write up here on the board 2 multiplication charts, or two times, and I'll know what that means. The next thing that I need to do is I need to multiply this 35i by negative I, and that is just a positive times a negative, so it's a negative. I have negative 35 just 2 times. Our multiplication chart, if you're, oh, so fancy, thank you. 35i squared. And this is the key difference between polynomials and complex numbers. With complex numbers, you can no longer leave I squared. I squared has to turn into negative 1. So my final answer is, it's going to be a negative 35 times this negative 1, which is a positive 35. So I really have positive, oh, what happened there? Positive 35 minus 210i.
Why is that?
Why is I squared negative 1?
Yeah.
It's kind of the definition of what I is. The definition of I is square root of negative 1.
Pattern thing?
Yeah, it is the pattern thing.
So we just, okay.
Time to go? Sounds good, thanks. All right, we're going to do another one of these problems, but this time using an area model. There's too much talking going on. Early, can you please turn around and face the board? I think that might cut down on the talking. If I create my area model, this again, before I even do the multiplication, is 2 minus 5i times the quantity of 2 minus 5i. And when I do that area model, I will get something that looks like this. There's still too much talking. Do I need to move people even farther?
I wasn't even moving my lips.
Sorry, I was dying.
Oh, for the senior thesis?
No, for basketball.
Oh, how many people are in basketball right now? Yeah, I don't know. I don't know what the game plan is. You guys are supposed to leave right now at 1:54?
Well, we have to leave at 2.
Yeah, okay. Basketball people, you guys are gone. Thank you.
Wait, when does the first senior thesis start? Halfway through 6th grade?
Did Miss Taylor put here? Let's stop the video. All right, so welcome back. If you guys left for senior thesis or basketball, you are now doing this for homework. So I'm now going to do 2 minus 5i on the top, 2 minus 5i on the left. And note that the minus sign is always going to be with the term. You don't put the minus sign in between here because you might forget that there's a minus sign. I always put it out to the left side. So 2 times 2, 4. 2 times negative 5i is negative 10i. Negative 10i yet again. And then I get negative times negative is a positive. 5 times 5 is 25. I times I is I squared. And we know that I squared is always equal to, everyone will shout out. Yes, very good, guys. Yeah, so negative 1. So that means that this whole thing is actually negative 25. So this turns into negative 25. And then I'm gonna add. So this was almost always the case where these top left, or top right and bottom left, will be like terms. I have negative 20i in this case. So I can write out the answer. This is going to be negative 20i. But I have this 4 and negative 25. That can also be combined. So with complex numbers, these diagonals also happen almost, I'm going to say like 98% of the time, will also be added. So 4 and negative 25, those are like terms. That turns into negative 21. So the final answer is negative 21 minus 20i. And I prefer you to put the real part first and the imaginary part second, but it doesn't matter. I mean, it's still correct either way. It's just not the typical form that mathematicians use. They typically use rectangular form, a plus bi form.
You have that wrong then?
Nope, you just leave negative 21 and negative 20i. That is the final answer. Yeah, good question. We are moving on to number 11, unless anyone wants to throw on the brakes by raising their hand. I can go back for a few seconds, but no hand is raised. You can always ask later as well. So I need to use the quadratic formula, the dreaded quadratic formula that I hate also teaching. I'm with you guys. It's just part of the standards. I'm sorry.
Wrong one. It's like
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Oh, I said it but didn't write it. Thank you. Yeah, so there's the quadratic formula. I expect you guys to be humming to yourself during this, or just to have it written down, I guess, on your note card, which is boring but more efficient, I guess. So let's go ahead and label all of these. A is 3. I'll point out A is not 3k squared. A is just 3, not 3k squared, just 3. That's the most common mistake I've been seeing in our class thus far. B is just 4, not 4k, and then obviously C is 5. So I'm plugging those in. Let's see what happens. So I have negative b, or negative 4 in this case. Negative 4, I should write out my x as well. X is equal to negative 4 plus or minus the square root of that same negative 4 quantity squared, which you can kind of leave off the negative 4 at that point, since you know a negative times a negative is a positive. If someone can let them in, I'm sure they either got kicked out or something. I don't know. Some bad thing happened. 4 times A is 3 in this case, and C is 5. How's it going, Fiona? What's up?
I'm just telling them.
Oh, did you guys, things are happening?
Yeah, basketball's leaving.
Oh, that's right. All right. This is all going to be divided by 2a, so 2 times, and our a was 3. And then we need to simplify, and we have all this room on the right-hand side to do that. So I'm going to come up here to the top right-ish area. So that negative 4 can't do really anything with him, plus or minus. Now I can start simplifying. So negative 4 squared, that is going to turn into 16. So I'm just going to write 16 above here, because I want to try to get all this in one step. I don't want to do math for ages and ages. 4 times 3 is... let's do 5 first. Which is oh yeah, 5 times 4. This is probably easier. 5 times 4 is 20. And then 20 times 3 is 60. So this whole thing is going to be saying minus 60. So I'm going to say that's all 60. And that bottom is going to be 6. So let's go ahead and rewrite it up here. It's going to be 16 minus 60. And that's being square rooted, all divided by 6. We have a few more steps left. I still have that negative 4 on the top. I still have the plus or minus. I still have the 6 on the bottom. The tricky bit is this square root. Yes, Loretta?
Oh, never mind.
Oh, okay. The tricky bit is the square root, because I'm going to get a negative on the inside of the radical. The radical is the name for that little symbol, right? I'm going to get negative 48 on the inside of that radical. And the square root of negative 48, I mean, it's fine. It might be one of the multiple choice answers that you have on the final. But you need to be able to simplify the square root of negative 48. And you say, okay, what times what is 48? Where hopefully one of them is one of those squares that I have up there on my living textbook, my classroom walls. What times what is 48? Where one of them is a perfect square. And it's hard. It's kind of tricky if you don't know your multiplication chart out to 16.
Did you just do 16 minus 60? Because that's because shouldn't there be like a 4 instead of a b if you're going with that? Because
Oh, what's happening? Yeah.
Something don't add up.
Is it negative 44?
I think it is.
Thank you. Yeah, log it. If anyone else caught it too, please log the extra credit point, including the people watching the video. I trust you guys. We have a bond of trust. 44, that is much, much easier. That's 4 times 11, right? And because every single time that you have a negative, and maybe you want to write down this rule because it's important, every single time that you have a square root of a negative, you're always going to pop out a little I out front, outside of the square root. That I represents the fact that you had a negative, and now I can leave the inside positive. So what I would like to write here, but I'm not going to, what I would like to write is square root of 4, square root of 11. That's technically correct, but the square root of 4 is 2. Exactly, yeah. So I'm going to come back here and say that's going to be I 2 square root of 11. Done. I could simplify a little bit if I wanted to, and here's how you could simplify. Just in case, this is probably the one that you'll see in the multiple choice, but you might see everything divided by 2. If I divide everything by 2, that turns into a 2. That turns into nothing, it's gone. That turns into a 3. If I divide everything on the top and bottom by 2, you are allowed to do that. That's negative 2 plus or minus, it's going to be I square root of 11 over 3. And that is the final answer that I'm looking for. Yeah, that's hard because not only do you have to memorize quadratic formula, you got to apply a lot of math, and there's a lot of room for error in there. All right, so your hand is up if you want to throw on the brakes. Otherwise, I'm moving on. Thank you for throwing on the brakes.
Last one.
So
Happy
you're
there's only one
dividing
piece.
everything by 2.
I'm dividing every single thing by 2 because that is just more simple. I'm kind of factoring out a 2 on the top, factoring out a 2 on the bottom. I'm kind of unofficially dividing everything by 2. Did I? Oh, never mind. All right, I want to move on unless someone else wants a little bit more time. All right, we're on to number 12. Factor each completely. Okay, so we have a giant factoring unit, which means we have a giant amount of factoring to do on the final. We're going all the way through number 21, just factoring. Whew, all right. Shake out your hands, and let's do this. This is going to be Ninja Star because we have 3 terms. Step 0 is always
Yes.
GCF. Yeah, thank you, Anna. GCF. Every single time, step 0 is always GCF. Check it every single time because about half of these have a GCF. We don't have a GCF in this case, so we're lucky. And then step 1 and 2 and all that stuff is like, oh, you can use Ninja Star if you have 3 terms. If you have 4 terms, you'd have to factor by grouping. Let's go through these one at a time. So this is a Ninja Star. Let's go ahead and show our work. On the bottom number, the thing that you have to add up to is negative 10. The thing that you have to multiply to is 16. So I'll do a little multiplication symbol on the top, a little addition symbol on the bottom so we can remember that. I multiply to negative 16. And again, I'm really multiplying this 16 times 1 to get that top number. And I don't need to do advanced Ninja Star since this leading coefficient is 1. I can just do this simple Ninja Star. What times what is 16? 1 and 16. That doesn't work. 2 and 8. Oh, yeah, 2 and 8 works. 2 and 8. And they have to add up to negative 10, so negative and negative. And there, we're done. We basically just have to rewrite our variable. It's n, not x in this case. So n minus 2 and n minus 8. And there is our final answer. All right. We are on to number 13. Step 0 always is GCF. Oh, this one does have a GCF. What is a GCF? You guys can shout it out. You guys know this. 2. Yeah, so when I factor out a 2, it's 2 times the quantity of x squared minus 3x minus 10. Now that I factored out the 2, it still will be my answer. Now I have to do Ninja Star on the inside. I'm using Ninja Star again because I have 3 terms. If you have 3 terms, it's safe to say you are going to be using Ninja Star. I can use a different color this time. Off to the side, Ninja Star. It's a simple Ninja Star because there's no number in front of that x squared. There's no coefficient other than 1. The bottom, or the middle, is negative 3. So negative 3, top is negative 10. And my question is always, what times what is that top number? 1 and 10. That doesn't add up to 3. 2 and 5. 2 and 5 will somehow get 3. 2 and 5. The 5 has to be negative. And then we're done, right? We just have to rewrite our 2 as well. So we have a... Yeah, question.
Does advanced Ninja Star also work?
Advanced Ninja Star will always work, yes.
Okay,
If
so when in doubt, advanced.
Exactly, yeah. Question, Lyria?
Can you just go over how to do the Ninja Star?
Yeah, so normal Ninja Star, right?
Yeah.
Normal Ninja Star, this number always comes down in the bottom. This middle coefficient always goes in the top. Yes. Huh, that's weird. This this last number always goes on the top, and this middle coefficient always goes on the bottom. My bad. I'm sorry.
Log that.
Yeah, log it. I'm sure most of you can probably log that one. You're like, wait, what is he saying? That's it. And then you have to ask yourself, what times what is the top number? What plus what is the bottom number? It has to be the same number on the left and the right. Yeah, perfect. So we have our final answer. We'll write it down here. I still have this 2 times the quantity, and then it's going to be x plus 2 and x minus 5. There is our final answer. All right. Anyone need a little bit more time? All right, then we're moving on to number 14. All right, step 0. GCF. All right, is there any greatest common factor between 4, 3, and 10? No. All right, that means we're going to do Ninja Star. This is one of the cases we need to do advanced Ninja Star because this number, this coefficient for the leading term, there is a number. It's not 1. It's some other number. So I'm going to do advanced Ninja Star. Here we go. This is how you do advanced Ninja Star. Advanced Ninja Star states I multiply the first coefficient times the last constant number. So 4 times -10, and I'm putting that on the top. -40. The bottom number is still that middle coefficient, 3. And the top left and the top right are always going to be your leading coefficient and this this term, but divided by 2. So if it was the power of 2 divided by 2, that's just x. If it was 4x to the power of 6, then it would be 4x3.
Divided by 2?
You divide this coefficient by 2, yes. I'm not going to give that to you, so it's probably a pointless rule, but it will affect you in pre-calc. In pre-calc, we do those lots and lots.
Basically, we just do
For now,
AX, like.
yes.
Okay.
For the final, it's always going to be this coefficient x. This coefficient x.
Oh, I see.
Yeah, I don't know why I keep overly complicating it. It's because I'm so used to teaching pre-calc, and that's the rule, and I have to I have to practice lying to you guys again. Yeah, just ignore that squared, and then you're good. Okay, then we are on to figuring out what times what is 40. 1 and 40. Darn, doesn't work.
I
Yes,
have a question.
yes, go for it.
You got -40 because you multiplied -10 and 4?
Yes, that is correct. The first and last.
All of them? Like all the examples?
All of the advanced Ninja Stars, yes. Yeah, good question. All right. So 2 and 20 doesn't work. 3 doesn't do anything. 4 times 10, no. 5 times 8. 5 and 8. That one works. All right. 5 and 8. Which one has to be negative to get a -40? Well, it's a positive 3, so it needs to be a -5. And then the next step is I need to reduce these pseudo fractions, or fake fractions. 4x over -5, I can't reduce that, so I'm going to leave that. 4x over 8. Oh, I could divide the top and bottom by, not by 2. I could do by 2, but then I'd have to do 2 again. Divide the top and bottom by 4. That's the greatest common factor. And then I'd get x over 2. Now I have my fractions that are correct. Let's go ahead and write out our final answer. My final answer is 4x minus 5, and this x plus 2. And I should keep an eye on the clock too, because we get out of here on Thursday at 2:22. We have 12 minutes left. And theoretically, for the people watching the video, that means you have 11 and a half minutes left of the video. All right, step 0 always is GCF. Is there a GCF?
Yeah.
What is it?
3.
There it is, 3, and then it's going to be 4x squared plus 12x plus 5. All right. That definitely makes these numbers a little bit smaller, a little bit more manageable. Again, I'm going to need to use advanced Ninja Star because this leading coefficient is something other than 1. So let's go ahead and set that up. Advanced Ninja Star. The top number, 5 times 4, we get 20. Bottom number is 12, that coefficient in the middle. And top left, top right, 4x and 4x. All right, what times what is 20? 1 and 20, darn. 2 and 10, hey, found it, 2 and 10. I don't even need to make any of them negative. Next step is I need to reduce those pseudo fractions. I'm going to divide the top and bottom by 2, and I get 2x over 1. Divide the top and bottom by 2 yet again, and I get 2x over 5. And there's my answer. Don't forget to copy down that 3 again. That 3 is being multiplied by 2x plus 1 times the quantity of 2x plus 5. All right, we're going to number 6. Okay, yeah, question.
Then don't make it into just a 2, that left-hand fraction, because it's not actually a fraction.
Yeah, it's exactly. It's not a real fraction. If it was, you're totally right. It would have just been 2x. I need to have a bottom number so I know what this guy is. That's why I left the 1 there. Yeah, good question, good question. Other questions need more time? No one? All right, we're going on to number 16. Don't be afraid to ask for more time. It's fine. This one. There is a shortcut, but there's also a long way. So here is the long way. Long way is, hey, if I have an x squared, use Ninja Star. Ninja Star kind of works for everything except Advanced Ninja Star. Works for almost everything except when you have 4 terms. 4 terms is the only one where you're like, oh, wait, factor by grouping. So, and you can do factor by grouping on all of these problems that we've done thus far too. If you're really, really good at factoring by grouping. I think Leo is the one person that's like, I'm going to do factor by grouping on everything. He has to learn one process for every single one of these factoring problems. It's kind of nice. So from here, I'm doing Ninja Star. And you're like, wait, Ninja Star is only with 3 terms. Here's how it's 3 terms. This is really 9x squared plus 0x minus 16. That's why I have 3 terms. Is that hidden place value keeper term. I don't know what you want to call it. It keeps the placekeeper. So I'm going to do Advanced Ninja Star. It never fails except for the 4 terms. All right, so negative 16 times 9. Dear gosh. Negative 16 times 9. And we don't have a calculator, so let's practice using without a calculator. Again, this is the long way. There is a shortcut way where you don't have to do 16 times 9. 16 times 9, really quickly after the size. 6 times 9 is 54. 5 plus 9 is 14, so 144. So the top is 144. The bottom is going to be 0 because the middle term is 0. It's missing, right? Top left and top right, 9x and 9x. What times what adds to, wait a second here, negative times a positive, Mr. Sindel, is a negative 144. Okay.
Negative 12 positive 12.
What?
Is it going to be negative 12 positive 12?
Oh, I thought you said negative 12,012. I'm like, that is a big number. You are correct that the answer is negative 12 and positive 12, though. Thank you, India. Yes. Negative 12, and positive 12. Yeah, these numbers will always match, but be opposites of one another. And that's what it means to be a conjugate pair, to get a difference of squares. And if you saw, oh, yeah, that's a difference of squares, you might know the shortcut already. Again, you're doing the long way of doing Advanced Ninja Star, which means I now need to reduce my fractions, divide the top and bottom by 3, get 3x over 4 and 3x. I ran out of room. I'm going to do it down here. 3x over negative 4. And that is the final answer, right? It's 3x minus 4 times the quantity of 3x plus 4. The shortcut method is, knowing that it's a difference of squares, I'll go ahead and label that for this problem as well. To say difference, I'm going to abbreviate, of squares. I cannot spell squares. If it's a difference of squares, you essentially square root the first one, square root the last one, and make it into a conjugate pair. The square root of 9x squared was 3x. The square root of 16 was 4. And then one of them is a minus, one of them is a plus. Done. That's a shortcut. Moving on to number 17. Step number 0 is always.
GCF.
Does it have a GCF in this case?
Yes.
It is indeed. What is the GCF?
2.
It is indeed 2. Yeah, 2 times the quantity of 4r squared minus 9. Oh, hey, what do you guys see? Squares. I see a difference of squares. There's a difference because there's a minus sign right there. Let's use the shortcut. The shortcut states square root the first, square root the last. So I have to leave the 2 there as well, right? And then I have some sort of conjugate pair. I know it's a conjugate pair because I'm going to do a plus sign and a minus sign. And as long as these 2 are the same and these 2 are the same, then it is a conjugate pair. So square root of 4r squared, well, the square root of 4 is 2. Square root of r squared is r, so 2r and 2r. I'll pause there because I've been talking really fast, and I want to make sure you guys can catch up. Again, the square root of r squared. I square root of the 4, and I square root of the r squared. The square root of 4 is 2. Square root of r squared is r. Then I ask square root of 9. 3. Done. Final answer, box it. Yeah, those shortcuts will save you lots and lots of time, but it does require more memorization or more work to be put into your... I don't know. I need another name. Note paper. Note card. I don't like note card. Card that implies it's like 3.5 by 3.5 by 5. I don't know. Someone can come up with a term for me. Okay, number 18. There's also a shortcut, but I'm gonna do the long way first. Question, Anna. Yes. So number 18 and number 19, just like the practice final, on the final, they are going to be the same types of problems. So number 16 and 17, difference of squares. Number 18 and 19, sum of squares. You can even write it down on your note card or whatever term we're using. Number 18 and 19 is a sum of squares, and write your notes for those types of problems. It makes it very straightforward. I'm trying to make this as, maybe I'm making it too easy. Now I'm going on to number 18. This is a sum of squares, but you don't know that. It just looks like another polynomial to you. Step number 0 is to GCF. Does this have a GCF? No. Oh dear gosh. Because we don't know the shortcut, this is going to require some intense multiplication because we have to go back to Advanced Ninja Star. Whoo! Can I not do the long way? Please?
Yes.
Okay. It works. It's just very mathematically intensive. Because we would have had to do 16 times 25, which, I mean, you can do. But here's a shortcut. If you know that it's a difference or a sum of squares, that means I do the same thing. Square root the first, square root the last. Square root of the first term is 5x. Square root of the last term is 4. You copy down, and this is kind of the part that most people forget. You copy down this sign.
It's this one.
And then square it. Done.
It's the square root of the first, square root of the double the middle, square root.
Square the first, double the product, square the last, but backwards. Exactly. Yeah, it's factoring.
Is that you square the first? Oh no, never mind.
Square the first, so 5x squared is 25x squared. Square the, or double the product, so negative 4 times negative 5 is negative 20. Double that is negative 40x. I forgot the x in the first part.
Square the first.
Double the,
Double product.
and,
Square the last.
exactly. But if you're going backwards, you square root the first.
The middle number.
The sign is the middle number, yeah. The product is the middle number, yeah. So that is the doubling of the product. Because the product, you can see here, negative 4 times 5x is negative 20x. If I double that product, I get negative 40x. That's where that middle number came from. It's doubling the product. All right. Number 19 is going to be similar, but it's going to have a GCF. So let's do step 0. What is the GCF? It's kind of straightforward there. Nice and easy. It was just 3n squared minus 4n plus 4. Oh, this one you could probably even use a ninja star. That one was pretty straightforward. But let's go ahead and use our shortcut again. It's a sum of squares. I keep saying sum of squares. It's not a sum of squares. It's a square. I don't know why I said sum of squares. It's a square. So I'm going to square root the first, square root the last. Square root of the first is, shout it out. Square root of the last is?
-2.
And then, yeah, what is the sign?
Negative.
The negative. And then quantity squared. Don't forget your 3 up front. Done. Box it.
Wait, where did the 4 go?
Yeah, good question. Someone else answer it. Where did the 4 go?
Which 4?
I'm guessing this middle 4 or the right 4.
The 4.
4n is the 2 times the -2 times n and then doubled.
Yeah, so if I was to factor this, or if I was to multiply this thing out, it's from doubling the product. But in terms of our shortcut, we can basically ignore the fact that that's 4n and just steal the minus sign. Again, this rule only works if it is a perfect square. The way that you can verify that it's a perfect square is by checking the middle term that Lorraine was talking about by saying, okay, what is negative 2 times n? Negative 2n. Double that, negative 4n. That matches with the middle term, therefore it is a perfect square. Yeah, if I were to scramble these up on you, then you'd have to check that, right? You're like, oh, I might need to use Ninja Star on this. And it would still work, especially on this one that has tiny numbers. We're on to number 20. Still, more factoring. This one has 4 terms. 4 terms do not work with Advanced Ninja Star, which means you need to do what strategy that I just talked about a few minutes ago? Say again? There it is, factor by grouping, which means parentheses around the first 2, parentheses around the last 2. Greatest common factor of each of them, make sure that your groups match. Greatest common factor of the first one, shout it out.
2m squared.
Oh man, so fast. It was 2, because that was the coefficient. And then I choose the smallest of these 2. The smallest is m squared, so 2m squared. What's left over should be, well, the 2's gone. M to the power of 3 subtract 2 is 1m, so, or m to the power of 1, so it's just m. And then 8m squared divided by 2m squared. The m squares kind of cancel out, and 8 divided by 2 is 4, so m plus 4. And hey, that matches up with m plus 4. So what is the greatest common factor that I can factor out of m plus 4? Nothing. If I can't factor out anything, you have to factor out at least a 1. And I will continue. I'll start on problem number 20 from scratch starting tomorrow. So you don't need to finish number 20.